All right, hello physics class. Today we are going to be converting the potential energy of a spring into kinetic energy. So, for those of you that have ever played something like airsoft or paintball, well, paintball works on gas, compressed gas. So, for those of you that have ever played airsoft or a Nerf gun, are familiar with this concept. You have a gun, and inside the gun there's a spring, right? And then there's your little Nerf dart or your plastic BB or whatever, and then it's in the gun, and you pull the trigger releases the compressed spring, and then your dart flies across the room. All right, so we're going to take a look at that energy conversion today. So we have a few givens to work with. The first is that there's a plastic ball or Nerf dart or whatever, and the mass of that is 10 grams. So mass is equal to 10 grams, right? We also know that there is a spring constant of 10 newtons per meter. So every meter that we compress the spring, it's going to be exerting 10 newtons. And the spring is compressed 10 centimeters. Right, so spring is compressed 10 centimeters. We have a 10 newton per meter constant and a 10 gram plastic ball. Now, the thing that we're looking for is velocity. We want to know its speed as it exits the gun. Okay, so what is velocity? Now, we already know what sort of energy system we're going to be converting here. We're going to be converting mainly the potential energy from the spring into kinetic. And we also know that within an isolated system, energy has to be conserved. So what this means is that the final spring energy plus the final kinetic energy is going to equal the initial potential energy from the spring plus the initial kinetic energy. Right, so that gives us a pretty comfortable place to work with. Now let's write out or break down these formulas. Potential energy from a spring is equal to 1/2 times the constant times the change in distance, or the compression or extension of the spring squared. Right, so that's our formula for potential energy of the spring. Now, kinetic energy, the formula for that is 1/2 the mass times the velocity squared. So we can sub that into these two formulas. Before we do that, I want us to think about this conceptually though. Now, when we start, there is no initial velocity, right? The Nerf dart or the BB doesn't have an initial velocity to begin with. It starts at rest and then it's acted upon by the spring. So if the velocity is equal to 0, what does that mean for initial kinetic energy? It's also going to be 0. So we have no initial kinetic energy. Now, also, as the spring fully is extended and imparts all of its energy to the spring, the change in x, the change in the distance for the spring is going to be 0. It's going to be at its original length, right? So the final potential energy in the spring is going to be 0 as well. There's going to be no potential energy left in the spring, right? So we're looking at a transfer of potential energy from spring into kinetic energy, something like this. So let's go ahead and set this up. We have 1/2 the mass times the velocity squared, that's going to be final velocity, is equal to 1/2 k change in x, delta x squared. Right, now all we have to do is isolate this v final, since that's what we're solving for using algebra. All right, first let's multiply this both sides by 2. So we multiply both sides by 2. That gets rid of these halves and leaves us with mv final squared is equal to k delta x squared. Now let's divide by mass to get that out of the way. So divide both sides by mass. That cancels out on that side. All right, now the only thing we are left with is the squared on v final, or the square on v final. So we go ahead and we square root both sides. That cancels out the square on v final, and we end up with v final is equal to the square root of the spring constant times the change in x squared divided by the mass. So we're going to save this, write it down up here, clear out some space, and then we'll plug in our givens and solve. All right, so let's see, once again we have v final is equal to the square root of k times delta x squared divided by m. All right, now a couple things before we dive in. These, you'll notice that these are not in the units that we want. So we're dealing with newtons per meter. If we're going to get this to cancel, we need this guy to be in kilograms because of newtons, and we need this centimeters to be in meters. All right, so 10 grams is going to be equal to 0.010 kilograms. Likewise, 10 centimeters is going to be equal to 0.10 meters. All right. Now that these are converted, we can go ahead and plug them into our formula. So v final is going to equal the square root of the spring constant, 10 newtons per meter, times the change in distance, 0.10 meters squared, divided by the mass, 0.010 kilograms. All right, we solve all that out using order of operations, and we should come up with 3 meters per second for the final speed of the pellet. 3.2 is what the book has. I'll accept 3, so pick your poison on that. All right, if you get stuck working through the homework or need any help with any of this at all, feel free to message me and we'll video chat, talk about it, figure some more stuff out. Until then, let's finish 2020 strong, and I will see you in the next video.